Hi and welcome to Trending Tech and More, the channel that brings you the latest in technology from across the globe. Do remember to give the video a like and subscribe to the channel to stay abreast of the latest videos. So without any delay, let's start.
The Milky Way and the vastness of space. With our present technology, crossing the Milky Way galaxy in a spacecraft would take an incredibly long time. The Milky Way is estimated to be about 100,000 light-years in diameter. A light-year is the distance that light travels in 1 year, which is approximately 5.88 trillion miles, 9.46 trillion kilometers. The fastest spacecraft ever launched by humans, the Parker Solar Probe, is currently traveling at speeds of about 430,000 miles per hour, 700,000 kilometers per hour. At this speed, it would take the spacecraft over 6,000 years to travel just 1 light-year. Considering the vast distance of 100,000 light-years across the Milky Way, it would take millions or even billions of years to traverse the entire galaxy using our current technology. This is far beyond the capabilities of any spacecraft we have built so far. Future advancements in propulsion systems and space travel may enable us to explore the Milky Way more efficiently, but for now, the vastness of our galaxy remains a significant challenge for human space exploration. With so many objects floating in space, how come we don't have collisions? The vastness of space and the relative distances between objects play a significant role in why regular collisions do not occur despite the large number of objects in space. Here are some reasons. Enormous space. Space is incredibly vast, with an immense amount of empty space between celestial bodies. The chances of two objects colliding randomly in such a vast expanse are extremely low. Low density. While space contains a large number of objects like satellites, debris, and natural celestial bodies, the overall density of these objects is still very low. The volume of space is so immense that even with a significant number of objects, the chance of collisions remains relatively small. Predictive tracking. Space agencies and organizations track and monitor objects in space using various technologies like radar, telescopes, and satellites. Orbital mechanics. Objects in space, such as satellites and spacecraft, follow specific orbital paths around celestial bodies like Earth. These paths are calculated and adjusted to minimize the risk of collisions with other known objects. Collision avoidance maneuvers. Spacecraft can perform maneuvers to avoid potential collisions. If a known object poses a threat, spacecraft can adjust their trajectory by firing thrusters to alter their speed or change their course. International cooperation. Space agencies and organizations collaborate internationally to share information about objects in space. This cooperation helps in tracking and avoiding potential collisions by providing timely alerts and updates. Design considerations. Spacecraft and satellites are designed with collision avoidance in mind. They often have shielding or protective measures to minimize damage from small debris and are built to withstand the impact of larger objects. Debris mitigation. Efforts are underway to mitigate space debris by implementing guidelines for satellite operators to minimize the creation of new debris and deorbit old satellites or space debris. However, it should be mentioned that the Andromeda is thought to have already collided with at least one other galaxy. A number of dwarf galaxies are presently colliding and merging with the Milky Way, including the Sagittarius dwarf spheroidal galaxy. Notably, the term collision is a little misleading. This is so since actual collisions between stars or planets are incredibly improbable due to the incredibly shaky distribution of matter in galaxies.